Good morning all of students. Today we meet again in online learning SMPK Penabur. I hope all of us in a good condition. This is our first meeting in the new academic year. Our meeting will talk about motion. This is the first chapter at grade 8. Standard competency. In our curriculum, standard competency for chapter motion is analyze linear motion, effect force on motion based on Newton laws, and its application on object motion and motion of living things. Motion. Branch of physics which learn about motion is mechanics. There are two branches of mechanics. The first is kinematics. Kinematics is branch of mechanics which learn about motion without consider the cause of object motion. The second is dynamics, branch of mechanics which learn about cause of object motion, which is force. Now we will learn about motion. To understand about motion, first we will see the figure below. The car located at point A. Point A is located 5 meters from the building. After that, the car moved to point B. Point B is located 15 meters from the building. From this we can get the description about motion. After we get description about motion, there are two important things we should know while we talk about motion. The first is reference, titik acuan. The reference is the stationary object. From the figure we can say the reference is building. The second is position. From the figure we can get that at point A located 5 meters from the building, point B located 15 meters from the building. So we can say the position is object location from reference point. After we understand about reference and position, now we can get the definition about motion. We can say that object if move, if the object position change continuously toward reference. Now we will learn about kinematics. After we have understand about motion, we will learn types of motion. There are two types of motion. The first is one-dimensional motion. This motion is linear motion. Jadi ada dua jenis gerak. Gerak yang pertama adalah gerak satu dimensi, di mana gerak yang termasuk dalam gerak ini adalah gerak lurus. The second motion is two-dimensional motion. There are two motions in this motion. The first is circular motion. The second is parabolic motion. This motion will be learned at senior high school. Gerak yang kedua adalah gerak dua dimensi, di mana yang termasuk dalam gerak ini adalah gerak melingkar dan gerak parabolik. Gerak dua dimensi ini akan dipelajari di SMU. In junior high school, we just learned about linear motion. There are several basic quantities we should know while we learn about linear motion. The first quantity is distance. The second quantity is displacement. The third quantity is speed. The fourth quantity is velocity. Now we will learn about distance and displacement. To get the definition about distance and displacement, first we will see the figure motion below. An object from start point follow the green arrow path until the finish point. The green path arrow represents distance. Beside green arrow, there are black arrow. Black arrow directly from start point to finish point. The black arrow represents displacement. After we see the figure above, now we can give the definition for distance and displacement. And this is the definition for distance. From the figure, we can say that distance is the length of path which is covered by the object without consider the direction which is it move. And the distance is given by symbol S. Jadi jarak adalah panjang lintasan yang dilalui sebuah benda tanpa mempertimbangkan arah gerak daripada benda tersebut. Jarak ini disimbolkan juga dengan simbol S. And definition for displacement is the shorter path between initial position and final position of the moving object at specific direction. Displacement is given by symbol delta x. That delta x is x2 minus x1. That x1 is initial position, or from the figure we can set as the start point, and x2 is final position. And this is the end position. After we have understood about distance and displacement, now we will learn about the definition speed and velocity. Speed is symbolized by v, is total distance traveled by object divided by total time taken. Because of that, speed is formulated by v equals s per t. And velocity is symbolized by v with an arrow above the letter v. The arrow represented a vector. So velocity is a vector because it has a direction. Velocity is defined as displacement of the object divided by the time interval. Because of that, velocity is formulated by delta x per t. To understand more about distance, displacement, speed, and velocity, we will see the example 1. First, we will see the figure below. Any move from point A to C through E in 20 seconds. Determine A. Distance, B. Displacement, C. Velocity, D. Speed. Distance AEC is represented by blue arrow. So SAEC equals SAE plus SEC equals 25 meters plus 60 meters. So SAEC equals 85 meters. And for question B, displacement is represented by red arrow. Because the displacement just depend on initial position and final position, so the direction for displacement directly from A to C. In here, displacement delta XAEC equals delta XAE plus delta XEC equals XA minus XE plus XC minus XE equals 30 minus 5 plus minus 30 minus 30 equals 25 meters minus 60 meters equals minus 35 meters. The sign minus is sign for the direction. The direction is to the left. So delta XAEC is 35 meters to the left. For question C, velocity equals delta XAEC divided by the time equals minus 35 meters divided by 20 seconds. So the velocity is minus 1.75 meter per second. And for question D, speed equals distance divided by time equals 85 meters divided by 20 seconds equals 4.25 meter per second. Now we will see the example 2. Bintang moved 28 meters to the north. After that, she moved 5 meters to the east, and finally she moved 16 meters to the south. If she moves in 20 seconds, determine A. Distance, B. Displacement, C. Velocity, D. Speed. To understand about distance displacement, first we have to draw the path that taken by Bintang. The path is shown by blue arrow, that 28 meters to the north, 5 meters to the east, and 16 meters to the south. So she moved from point O and E and finally to point S. Because of that, the distance equals 28 meters plus 5 meters plus 16 meters. So the distance becomes 49 meters. And for the displacement, because displacement just depend by initial position at point O and final position at point S, so displacement is shown by red arrow. Because of that, the displacement delta x equals square root 5 square plus 12 square. So delta x equals square root 169. So the answer is 13 meters to the northeast. And for the point C, velocity equals delta x divided by time taken. So the velocity becomes 13 meters divided by 20 seconds. So the answer for velocity is 0.65 meter per second. And finally, for the speed v equals distance divided by time taken, or s divided by t. So v equals 49 meters divided by 20 seconds. So the answer for the speed equals 2.45 meter per second.